All right, well, greetings, colleagues. Thank you so much for joining. Good morning, good afternoon, good evening, wherever you are. So we're here for a session on coastal zones as part of this GEO Virtual Symposium, and specifically the Earth Observation Partnership between GEO, the Group for Earth Observation, and CEOS, Committee on Earth Observation Satellites, the COAST activity. CEOS COAST is short for Coastal Observations, Applications, Services, and Tools. And we're also going to bring in some of our other broader international partners in this UN Decade for Ocean Science for Sustainable Development. So myself, I'll be leading the session, Paul DiGiacomo from NOAA. We will also then go to Raj Kumar from the Indian Space Research Organization, who's my fellow co-chair with CEOS Coast. Then we'll be going to Douglas Kripe from the GEO Secretariats. We'll be speaking about, Raj will be speaking to the COAST activity briefly. Doug Kripe will be speaking to the interest in common between GEO and CEOS. Then we're very happy to have Nadia Pinardi from the University of Bologna, who will be speaking about the CEOS Coast partnership with Coast Predicts, a recently selected program for the UN Decade. Then we'll be going to Dr. Rashmi Sharma from the Indian Space Research Organization to discuss a pilot project that's kicking off in the Bay of Bengal. And again, the goal of the session is to introduce this common interest between CEOS Coast, and GEO, and our international partners such as Coast Predict. And with that, we will get started with our first speaker, Dr. Raj Kumar. So Raj, take it away, please.
Yeah. Good morning, good evening to all. As Paul has already described that what is our goal of this session, which is mainly on the CEOS Coast. As he also told, the CEOS is an organization of the Committee of Earth Sciences for the many countries, 62 countries are there, agencies total overall, working toward that mainly to humankind observations for the benefit of them. And under that, coast has been one of the, as all of us know, that is one of the major player in the ocean, because many things are being done for the ocean also as well as the land. But as we say, coast is very, very important, but somehow it was not taken a much important role in the CEOS also, as well as the how this will be getting benefited for the many players, many stakeholders, what we will be just discussing in a short while. So that's why this CEOS Coast was started last year itself in the CEOS plenary. Mainly the role of this CEOS Coast is to all these elements, what we call it, observations as well as applications, and then with the tool development, because not only some application, if you demonstrate, it may not be useful for the actual last mile. So that tools also will be developed under that, and then also services. So everything what we are planning to have under the CEOS Coast team, and that we will be discussing mainly for the societal benefit. As I told, overall CEOS itself is for the societal benefits, but under the coast, for the coastal zone area, I will come up on the next slide for that purpose. So that is a major what we want to do under the CEOS Coast. And it will be mostly helping you, all of you, through the mainly the Earth observation satellite data for the community, whole community of the coastal community. This is how it will be useful by the development of the products, number of products, what we are planning initially to solve all this. We can't say all problem, but most of the problem for the coastal regions, what we find presently, what we can thought about those problems we will be first taking up, and those products and some of the advanced products, and that some features or applications of what you people will like to have, that we will be discussing afterwards with all of you as all stakeholders, so that we can develop useful products or useful applications. So for that we have planned in our pilot projects, mainly two pilot we have thought about. One is the, as you know, impact of land on the sea, and the second one is the impact of the sea on the land. In the sea to land impacts, mostly it has four focus areas what we presently thought about. One is the physical oceanography states and the forcings, which are, as you all of us know, some of the forcing we can say ocean waves, winds, tides, sea levels, and one of them very important is storms in the coastal zone area. Second focus is on the near-shore coastal bathymetry, because this is very, very important parameter when we talk about the coastal zone areas. Third is in this is the coastal characterization, such as shoreline mapping, elevation, land use, land cover. And fourth focus is on the coastal flood and inundation mapping. Mainly, this is happening due to the hurricanes, storms, what we call here in the cyclone. In the second phase, what we call as pilot projects, impact of the land to the sea, it has mainly two focus areas, what we call it sediment loading and coastal eutrophication. As you know, the sediment is supplied by rivers as well as the winds or the erosion from the shoreline due to all these waves, tides, and currents are very, very important for the biogeochemical cycling. And then sediment loading to coastal regions, which affect that mostly, we know, the fisheries, spawning ground, and shellfish beds, and all those. So these are the main focus in these two pilot projects, land to sea as well as sea to land. In the theme, as a left hand side we are saying, mostly these are the themes what we will be talking in the coastal these two projects. And these are the locations, presently pilot locations what we find, because all the coast all over the globe is important, but what we are thinking about that these are the pilot locations what we had initially thought about in the continental point of view. One is the in the Bay of Bengal, Orissa region, then Chesapeake Bay, USA, West Coast Africa, and then Rio de Plata region. In that, if you see the right hand side, these are the some of the themes what we call it. One is the inundation in the left hand side, where you see the inundation over, this is a recent cyclone, inundation over the Indian region in the near the Orissa coast. Then bathymetry, as I told, is very important. So this is the product has to be developed with the higher accuracy, which can be used for the with the DEM for the inundation purpose. Then one is the how the coasts are changing. That some of the examples we are just I'm talking. These are the some examples of what work has been done at some level for these things, as well as the sediment transport. Next, please.
1 minute, Raj.
Yeah. Yeah.
Do you see the slide?
Sorry, please go ahead, Raj. 1 minute, Raj. 1 minute left.
Yeah. Okay. Yeah. So yeah. So this is the last slide. This is so what we want to do. We want to have the continued discussion with all these stakeholders for this purpose. And for this, what we are planning, this is one geo. We are anyhow today we will have some discussion, and then in October 5th also we are planning a showcase meeting with some examples, concrete examples we will be having. And presently, we want support from all of you to understand the requirements and what type of operational products we want to see, as well as the applications. And these are some of the our magazine we have put about the this observing coast, this CEOS coast. You can go through this. You can get some about that what we are want to do and what we are doing, as well as in the CEOS. So that's all from my side. Thank you.
Great. Thank you very much, Raj, for introducing the CEOS Coast project. We're now going to Douglas Cripe from the GEOS Secretariat. Doug?
Thanks, Paul. So I'm going to just briefly touch on some of the ways in which the the geo community and the members of participating organizations can connect with and support the work of CEOS Coast. The most obvious place, I guess, to start is to look at the GEO work program itself and see what is happening in terms of marine activities and or closely related. And as you can see here, I've compiled just a short list of flagships, initiatives, community activities, and foundational tasks. Some of the objectives of CEOS Coast. Geobond, in particular marine bond, is kind of a fairly obvious choice, as is Oceans and Society Blue Planet. AquaWatch with its inland and coastal water quality objectives, and then the initiative on Earth observations for sustainable development goals, in particular with SDG 13, and Digital Earth Africa, which is a new initiative. And then there are a number of community activities also that we could potentially find some synergies with. You can see here Earth observation for the Atlantic region, global observations of deltas and estuaries, and then Arctic GEOS, which is being led by SEON, the Sustaining Arctic Observation Network participating organization within GEO. And then looking a little further afield, there is a community activity that's working to help those who are interested in defining or looking at essential variables and some of the commonalities across GEO who are working towards this. There are, of course, as you know, the essential climate variables, and then those have expanded now to essential biodiversity variables, and there's work on essential ocean variables and so forth. So, and then the Open Earth Alliance community activity is working towards making open source geospatial platforms the work of GEO. Then there's the foundational task on GEOS data in particular. Under this foundational task, you have the work of the GEOS platform, which again provides data access and data discovery and access. And then the Geo Knowledge Hub, which would take some of the services, as Mar just showed us, and allow those to be reused through packaging of all the information that's available there. And then the regional geos would be another way of approaching, in particular working with AfriGeo, AmeriGeo, Asia Oceania Geo, and EuroGeo. These, of course, take a more regional focus on some of the issues and challenges facing these particular regions and finding common ways of trying to approach them, so that would encourage data sharing and so forth. Then if we move away from the work program itself, out in the GEO community, there are a number of bodies that, that would be synergistic with the goals of CEOS Coast. Of course, the participating organizations in GEO, of which there are many that are marine related, such as the WMO, the UNESCO IOC, GOOS, and so on, and of course CEOS, we don't want to forget CEOS. So there's a number of partnerships potential there. There are the working groups across GEO, the climate change working group, the capacity development working group, the disaster risk reduction working group, and the data working group. Each of these have a different focus, but for example, the data working group might be willing to work with CEOS Coast to determine how data sharing can be leveraged, and some of the GEOS data sharing principles and data management principles could be applied. Then there is this rather new entity called the Pacific Island Advisory Group, which advises the Executive Committee on needs of the Pacific Islands. So as Raj just mentioned, there's some interest in the Marshall Islands. A way to create. And then the Geo-Indigenous group also
Doug, you're breaking up a bit. Doug, we can't hear you right now.
So I was just saying, can you hear me now? Hello?
Yes, Doug. Yes.
Okay. Sorry about that. My bandwidth is a little unstable today. Geo-Indigenous Alliance would be another place where you could get feedback in terms of maybe in Arctic regions where concerns around FAIR principles and CARE principles would be of interest. Then finally, there are some new opportunities that we're looking forward to, and that is the recent support or endorsement of the GEO Executive Committee towards support of the UN Decade of Ocean Science for Sustainable Development. And then as you will find on Wednesday of this week, one of the plenary sessions is going to focus on this nexus idea across different domains, and in particular, the ocean climate nexus and how these play off each other, what trade-offs are involved, and how Earth observations can perhaps support some new initiatives in this area. So that's just a very quick tour of some of the ways in which GEO can be supportive of CEOS Coast. There are many other areas that I haven't mentioned, especially in the work program, but I think that gives you a good flavor of some of the places to start. So thanks. Back to you, Paul.
Excellent. Thank you, Doug. On time, and our numbers are significantly growing. And so we've heard from Raj about CEOS for the Newcomers Committee on Earth Observation Satellites, the CEOS Coastal Interest and Activity, from Doug about from GEO perspective and the engagement with the various coastal initiatives at all. And so now we're going to go to one of the key activities in the recently announced UN Decade for Ocean Science for Sustainable Development Goals, which is the Coast Predict program. Turning it over to Nadia. Nadia, please.
Thank you very much, Paul. So thank you for inviting us, and I would say representing Willy and Joaquin Tintoret, Willy from University of Miami and Joaquin Tintoret from the Balearic Islands. Our program is very much interested in having a very stable and continuous connection with Costa, with CEOS Costa. We want to pursue a predicted global coastal ocean, which requires, information about all the variables that we mentioned, that you have mentioned before. We are focusing on a major science leap forward step, which is understanding the new feature, the global ocean. The global coastal ocean, we call it the global coastal ocean. Next, please. Yes, our program was co-designed in the past year, and here you see CEOS Coast was very active with us, as well as GeoBlue Planet. Next, please. We are also co-designing with Goose. We are one of the 3 programs approved for the UN Decade. Coast Predict wants really to integrate observations and modeling in order to solve some of the issues in disaster risk reduction and climate. Next, please. Why Coast Predict? Next, please. We know the famous Aqua Alta event in 2019. Coastal models, coastal observations don't give enough information. We are doing already better with the Copernicus Marine Environment Monitoring System. Next, please. Coastal forecasting models have less accuracy than large-scale models and too short forecast lead times. So that should not be. We know scientifically that makes no sense. We need also to accelerate closing the gaps with ocean weather and climate and value-added processes that are involved. Here you see one of the latest successes of these ultimate downscaling models. Next, please. And you see accuracies that were not possible before by using new tools. Thank you. Next, sorry. So the major aim, as I told you, is to redefine, maybe back, please. One back. It's to redefine the coastal ocean. So I've already seen this land to sea, sea to land. So we want to define this area of transition. And we have, you know, it was already started in the scientific literature, but we want to revise. We go much more inland than previously. And we want to adequately cover the urban domain of the coast. Thank you very much. Next one, please. So the coast predict high-level objectives are a predicted global coastal ocean, the upgrade of a fit-for-purpose oceanographic information infrastructure, and the co-design of an integrated coastal ocean observing and forecasting system with a standard designed in a global framework but implemented locally. Next, please. I don't think I have time to go through the principles. We like to have projects under the umbrella of the program that have several specific principles, among others, end-to-end demonstrations, clear stakeholder engagement plan, have at least 3 ocean areas of implementation and comparison. Next, please.
30 seconds.
Yes. So the cost predict new knowledge. This is the first draft. So how are the costs similar? How different? Thank you. Next, please. And you know, among above all, high resolution satellite images for the coast, such as the one that Sentinels allow us. We have new sensors, communities getting inside Coast Predict. Next one, please. Coastal urban oceanography for impact forecasting. This is during the hurricane in New York. And next, please. I'm almost at the end, I hope. We want to integrate across scales, the observing and the predicting system, and both for the satellite and the in situ data and the models. Next, please. And we have also a special action on nature-based solutions against storm surge that is mainly based also on satellite retrieval. Next, please. Yes. So thank you very much for the attention.
Excellent, Nadia. Thank you so much. Very nicely done. So, and we just heard from Nadia on a very important program for the UN Ocean Decade in terms of Coast Predict. And so we've started the flow of the session very purposefully, the Earth observation perspective from CEOS Committee on Earth Observation Satellites and the engagement and the partnership with GEO. And Nadia just spoke of the very importance of the value chain going from observations and data into products and information and the translation that occurs with the coastal forecasting and coastal predict. And now really talking about focusing on specific phenomena in a specific region. We'll go to Rashmi with the Bay of Bengal demonstration and Dr. Sharma from ISRO. So Rashmi, please.
Thank you, Paul, and greetings for the day to all. So this is going to be a very brief presentation on the sea to land theme with a focus on the Bay of Bengal region. So a little bit of background, the east coast of India is very frequently affected by the cyclones. That is because the Bay of Bengal is very warm and the stratified ocean. And these cyclones predominantly happen during the pre-monsoon and the post-monsoon times. So associated with these cyclones, a lot of damages happen and a lot of inundation, flooding, etc. happen. So in order to assess the extent of damage, models that are put in use, they require very high resolution bathymetry and the digital elevation model. And these two are also the very key component in storm surge inundation prediction. So bathymetry estimation, hence it becomes a very important, and it is a central activity under the sea to land theme, wherein we are planning to make use of both the SAR and the optical data for the estimation. So the key question that comes up is which pilot site to select. And in the several of the coast meetings that we have participated, we have deliberated a lot on the pilot site selections. the accuracy of the estimated bathymetry required, the analysis ready data which is required to estimate the bathymetry, the analysis ready data from the resolution, corrections, portability, format, etc. point of view. And one of the most important data set which is required to validate our entire chain is a validation in situ or the ground data, wherein we are planning to bring in other national agencies on board who are having this data. And we also talked about how the results or the data will be shared among the coast partners. Next slide, please. So coming to the pilot site selection, if you see this cyclone hazard analysis map, which has been prepared based on the frequency and the intensity of several cyclones, you will see that the east coast towards the West Bengal, North Odisha, and the South Odisha, the region which is marked in the black ellipse. So that is the region which is highly prone to the cyclone activity. And hence, for our pilot site, we have selected this region for taking up the case study. Right-hand side, what you see is the list of satellite data requirement, which we need to address the problem. So I'm not going to read out, but these are the parameters like shoreline, depths, river discharge, land use, land cover, water temperature, physical oceanographic parameters, salinity, altimetry, winds, and wave data. So next slide, please. So what I'm going to do is, in this slide, I'm going to present glimpses of the monitoring and predicting the sequence of events for a particular cyclone. However, this is our routine activity. And this is the example which I'm showing is for a particular cyclone, which is Phylline, which happened in October 2013. So we make use of different types of data sets to monitor the cyclone. We make use of the geostationary satellites, thermal infrared to see the center and the structures. And then the middle one, which you see, is a very beautiful image wherein you can see the eye of the cyclone in the ocean sat to ocean color imagery. And the vectors which you see is from the same platform from the scatterometer winds. Along with that, we also make use of numerical model to simulate and predict the water level, the surge height, and the wave height during the cyclones. So these, some of the examples are shown here. And once we do the prediction and the simulations, we also validate the water level and the wave height also. So here I'm showing you the examples pertaining to the water level. And you can see that the storm tide from the tide gauge has been made to use to validate the model simulations. And the detided water level, which is essentially the surge residual, that also is plotted on the right-hand side. And they correlate very well with the correlation coefficient of 0.97 and the RMSE of 6 centimeter. So this is our routine activity, and we are engaged in this kind of end-to-end chain of activities for each of the cyclones. Next slide, please. So having seen that in modeling the surge and the inundation, the bathymetry becomes one of the very critical elements. So, and normally what we use is the bathymetry from the JEPCO, which is a standard product, but these bathymetries are highly region specific and they are also data constrained. So in this synthetic aperture radar and the optical data set, they offer good advantage in deriving the accurate bathymetry for the intermediate range of depths, like from 10 to 70 meters. So talking about the SAR, there are two algorithms which are widely used. One is based on the ocean wave refraction, which is a little bit fairly simple, because it is based on the general dispersion relation. And the second method which is used is the wave current interaction, where we use the forward model to simulate the sigma naught, and then we use the we minimize the observed and the simulated sigma naught. As coming to the optical data, it offers a very good prospect of retrieving bathymetry. And I will show you one example, and it offers basically the estimation based on the sunlight reflection from the sea floor in a clear water up to a depth of 15 to 20 meters. Different types of algorithms are used for this estimate. However, for the coast, what we have planned is that we will be going for a synergistic approach or a hybrid method, where from coast to breaker zone up to 15-meter depth, we are going to use the optical method. And beyond the breaker zone, up to nearly 70 to 100 meter depth, the SAR-based bathymetry we are going to estimate, and then see how good they simulate the surge height and the inundation. Next slide, please. So here you see the bathymetry estimation, which my colleagues have carried out here using the SAR image. And for this, we have used the pulsar, ELOS pulsar. I'm sorry for the spelling mistake of ELOS. And they have been, it has been compared, the derived bathymetry has been compared with the in situ observations based on the echo-sounder data. And the differences are within the range of -2 to 3 meter. So which can be considered as a good estimate from the SAR bathymetry, so from the SAR-based observations. Next slide. So we have also developed algorithms to get the bathymetry from the optical data. And for this, my colleagues have used the Sentinel-2A and 2B. And also the validation data set was used, the sounding data, which was from the jet ski. And different types of algorithms were used to estimate the bathymetry from the optical data. But the one which showed the maximum promise was the support vector regression model. And it resulted in the best performance with the least RMSE of 38 centimeters in the depth range of 0 to 15 meter. So the different algorithms which have been used for the bathymetry estimation from the optical are shown on the right hand side of this slide. But the best one was from the SVR method, which is a AIML based method. Next slide. So this slide shows basically the inundated area as mapped by the Sentinel SAR, and it is for the cyclone Tokte that hit the west coast of India in this year in the month of May. The left image shows the SAR image and the pre-cyclonic conditions, and the adjoining images for the post-cyclonic, and the marked regions with the red circle you can see are the inundated regions. And based on the several days of images, a composite inundation map also was prepared, and which is shown on the right hand side of this slide. The marked region, the two regions which are marked with the red ones are the regions which were heavily inundated due to this cyclone Tokte. Next slide. This is yet another example of flood inundation due to Fani cyclone. The left-hand side image, what you see is the pre-cyclonic image, which was, it is based on the optical image, and which was obtained from the sensor at AWIFS onboard ISRO's ResourceSat-2A satellite. And the middle one is after the cyclone. And once again, we see the regions which were inundated due to this cyclone. And the right-hand side, what you see is for the another cyclone, the flood and the heavy rain inundated area in parts of the West Bengal state using the Sentinel-1A SAR data. Next one.
1 minute, Rashmi.
So, yeah, yes, I'll complete. Yeah, so this is the modeling effort. What we showed in the previous two slides was about how we monitored it using the satellite data, but this is our modeling effort, which is needed to have a flood alarm system for the flood relief and rescue operations towards effectively managing the flood management, and also to provide inputs to the disaster management authorities. So towards this, a numerical model is routinely used in which several static and dynamic data are prescribed. And actually the model skill also has been tested, and it was found that the flood discharge estimation with 50 hours of lead time has an accuracy of more than 85%, so which is quite good. And this information is actually provided in real time for the flood alert dissemination. The right side shows a few, the same example of the early warning flood monitoring system. Next slide, and the last slide. Yeah, so this is what is going to be our plan ahead for the coast activity. What we have done is we have selected, after several discussions in-house, we have selected a cyclone Amphan as a test case. And the left-hand side, what you see is the end-to-end chain of activities that we are planning out to generate the product, and that we expect to showcase under the COAST meetings and also for the upcoming meetings. So we will start with the JTWC best track input, and then we will follow all the steps. I will not read out, but what I can say is that we will be making use of the model, the different types of satellites, satellite observations, and inundation modeling, surge modeling, and all. And then the final demonstration and the showcasing of our results we are going to show in the upcoming host meetings and also in the plenary meetings. So this is all from my side, and I thank you for the opportunity.
Thanks, Rashmi. So I think Rashmi did a very nice job of highlighting some of the integration challenges that are very much germane in the coastal zone, and particularly looking at that land-sea interface. And this is where challenges that CEOS is tackling includes analysis-ready data, which is ensuring interoperability of the different data sets. But Rashmi also highlights the need to integrate the observations, both satellite and in situ, and with the modeling. But finally, to ensure that we generate information that provides actionable knowledge for the users, in this case, in terms of the flooding and the inundation. So Mary Beth now is asking for questions in the chat. And so just to summarize, so again, what we tried to do is give you a little bit, a very quick snapshot across the value chain, but talking about the Earth observations from the CEOS perspective, particularly the satellite, but also the integration with the in situ observations and working with GEO together in that regard. And then likewise, the Coast Predict, the coastal forecasting prediction capabilities in the broader context of the decade. And likewise, we plan on working with other partners in the decade. For example, the Marine Life 2030 has been selected as a program. It's part of the GEO Biodiversity Observation Network, and Frank Miller-Carter is on the line. And then, but again, finally, then the integration of these different data products to provide information for users. So let's go to questions. Mary Beth, do we have some questions in the chats? And if not, I will pose one just to prime the pump. So to ask folks, what do you feel is one of the most significant observing system gaps in the coastal zone? And, you know, particularly thinking about that from the integrated land-sea context, and, you know, be it satellites, be it the in situ data, be it the modeling output forecasting. So interested in hearing about what folks feel are some of the key gaps for us to collectively address across CEOS and GEO and working with the partners in the UN decade.
Just letting people know you can unmute yourself to respond.
Yes. And for those that don't, thank you. For those that don't know me, I will call on people in the chat, so be prepared if we don't have questions. So Frank has a question. Thank you, Frank. To what extent do you see coasts seeking to evaluate, predict life, and venturing to do biogeography like seascapes at high res and monitoring biodiversity? So good question, Frank. Is in the given coast from CEOS as a UN decade contribution, right now we're focused more so on some of the coupled physical, biological, biogeochemical impacts, the latter particularly being water quality in the coastal zone and looking at sediments loading, looking at nutrients loading, impacts on eutrophication. But I think in subsequent phases, Frank, to look at the broader ecological impacts, as you just said, so to look more in habitats, particularly benthic habitats, to look at the pelagic habitats, for example, the fisheries, and to do some of the biogeographic activities like the seascapes activity that Frank has been helping to lead. So in our subsequent phases, we're in phase 2 of COAST right now. I would say that that's an activity for phase 3 and beyond that we will flag more so into the biological impacts in the coastal zone, as well as looking at other regional impacts, particularly high latitude, which I think is also germane, Frank, given climate change impacts and the movements of the critters. Other questions? Okay. So Mary Beth, I believe, is asking, what's COAST potential products? Again, looking at the land-sea interface, and we're looking at the oceanographic parameters. You know, Jerome Benvenista's on the line, looking at sea surface heights and winds and waves and tides, and looking at coastline change, looking at flooding, looking at changes land cover, land use, and then runoff and nutrient loading. So what do you folks think are of interest in terms of what we've laid out in COAST, or things we haven't discussed?
Paul, can I say one?
Please, Nadia.
You know, one major issue, as it was stated, is the bathymetry and the digital terrain model that goes, you know, inland. There is a serious need to evaluate, you know, how to update continuously the products, the frequency for operational release, also of these upgraded products for the changing coastlines. You know, events can modify radically the coastline. We need to have a continuous assessment of that. So bathymetry is a very big issue that our community, more the coastal modeling community, and also the biogeochemistry is looking for from the satellite community. So that is a very important activity. In addition to, which we see in several estimates, the combination of satellite and in situ to calibrate the satellite. So, and it's an old topic, this one, but if we could, for the coastal area, find a way to define a standard, that would be really worth, I think, the effort. In situ versus satellite for calibration validation of the satellite data.
Paul?
Paul, you're mute.
Thank you. Sorry. Excellent. Thank you. Excellent intervention, Nadia. And that is definitely a high priority of the COAST program, to look at the satellite-derived bathymetry and to get global coverage, and not just for developed, but developing nations. And again, the validation will be a challenge, and really need that coupling with the in situ observation. So thank you, Nadia. Prakash, good to see you. Paul, are you planning to model land-derived nutrient runoff in coastal waters? So I'll give two answers to that. Excellent question, Prakash. The first thing we're planning on doing is to work on a new and improved indicator of eutrophication, working with some broader community activities out there, which will be an artificial intelligence machine learning approach to use space-based and field measurements on both sides of the land-sea interface, but really with an eye towards being able to take what limited nutrients measurements we have and develop an AI indicator leveraging satellite data. The building on that, I think the next step will be for us to work with Coast Predict, and because that question is very much in the short-term priority list for Coast Predict, and working with data providers like CEOS to do some of that modeling of looking at the nutrient runoff into coastal zone, and then what are the subsequent impacts. Maria has a comment as well in terms of coastal erosion. So, and have there been improvements satellite observation scale? So we are going to tackle that likewise at first indirectly, Maria. I think in looking at some of the sediment runoff and some of the impacts, there have been some improved capabilities, particularly one of the challenges in the coastal zone, as we're all aware, is I think the need for higher spatial, temporal, and spectral resolution satellites. And there's been great strides made in the past few years by the CEOS agencies, and likewise upcoming. And I think those new and improved satellite observations, Maria, are very much going to benefit looking at coastal erosion, particularly to some of the spatial observations, the great imagery we have from Sentinel-2, from the European Copernicus program, and then likewise, you know, Landsat 9's coming but even getting down to some of the higher resolution commercial imagery from Planet and some of those other platforms. And also, but like I said, increasingly some of the higher resolution observations, temporal observations from geostationary, we're seeing more agencies come up with those. Jerome, the river discharge and the coastal, yes. And and Rashmi gave a good example, that coupling, again, looking at the runoff and the storm surge and that integration across the coastal zone. So thank you, Jerome. Other questions? Mary Beth, if you want to seed some additional seed comments for the group. Okay, Marco, thank you for the presentations. I have a question regarding the Bay of Bengal example. Rashmi, let's have you speak to this. Have there been tests of applying the model to different regions? How well do you think the model is transferable to different regions? Rashmi, can you speak to that, please?
Yes, Paul, I'll give answer to that. Actually, this model which we have set, this is for the east coast of India and also for the west coast of India. So this setup works pretty well for these two regions. However, we have not tested it for the other regions, but that's a very nice suggestion, which we will definitely look into. Yeah, thank you.
Thank you, Rashmi. And Marco, it's an excellent question that one of the goals of CEOS Coast is to demonstrate capabilities but ultimately in leveraging where we have kind of a critical mass of observation, satellite, in situ and modeling capabilities, but to really demonstrate those and do technology transfer for other regions across the globe, because these are common concerns everywhere in the globe. So we have some good follow-up on the erosion. Thank you for Jerome. Getting back to Maria's question. Thank you, Nadia. I'm looking at, again, obviously, and we didn't have time to set up, but obviously key thing in the coastal zone is you have where land, sea, atmosphere, and people meet. And so you have those interesting integration challenges and opportunities. And it's not just the environmental observations, it's also the coupling with the social sciences. And that's particularly where we're working with GEO, with the Geo Blue Planet Initiative and the AquaWatch Initiative. So Mary Beth asks a good question. We're very much interested in the coupling between satellite and in situ data. I'd be interested in anyone saying if they have good data sets, in situ data sets for our pilot regions, the Chesapeake Bay, the Bay of Bengal, west coast of Africa, Mar La Plata, down in Argentina, some of our islands. Okay, we have some good additional follow-up to Marco. Other questions? Okay, so let me throw out another question. Do folks feel that there's barriers, any of our users and our other colleagues here, barriers to participation in the CEOS Coast activities or the GEO activities that we've spoken in the UN Decade? We're really much encouraging participation for all, and really it's just an expression of interest to hear from folks. That's all you have to do, is just say, yes, we're interested, and we can make the connections for you. Okay, other questions from the audience, and folks can even go on the mic if they like. What do folks feel about the quality of the data that's available right now, and where do you see some of the biggest challenges but opportunities to increasingly improve the quality in the coastal zones? And again, not just product quality, but also sufficient space, time, and spectral resolution. Oh, tough group. Okay.
I think we'll
Well,
also.
I can answer my. Hey, Raj, I can answer my own question, but Raj, please.
No, I was talking that another question can be actually what stakeholders are looking for. what are the present gaps, that is what they want from this course team or maybe the developers, what exactly is required, something that we can talk about it.
So if I must say something about this in a certain direction, we found in Europe, across the different coastal regions, a serious need to plan remediation actions, also sometimes nature-based, some other times with constructions. And, modeling with calibration validation from satellite is essential. So they are starting to use more and more what-if scenarios from calibrated models in the past. And we find that the possibility of using satellite data for coastline evolution and bathymetry and coastal erosion patterns is really key to show the value for the past so that you can plan better the future.
Great, thank you, Nadia. Thank you, Raj. Prakash indicates correctly. So a major gap area is intertidal, the DEM, digital elevation model for land sea interactions. Any plan to use the multi-tidal information to generate the intertidal? Rashmi, I don't know if you want to speak to that.
Yeah, actually, that's a very important point. However, to generate them at such a high resolution, I think we need maybe something like LiDAR observations or very high resolution data set. So we will see how we can do about that, but it will definitely help us in modeling the inundation in a much better way. So that we can take it up as a gap area, and we can deliberate upon this.
I would like to.
Thank you, Raj.
I would like to add into that. Yeah, I would like to add, because DEM, for exact DEM, this will be required, the LiDAR type of things. But really, by using the optical data itself, by using the LLT, low-level tide, or HLT, HTL, sorry, STL and LTL, we can monitor these things, how much erosion happening and how much this, because that data is very frequently available. So those things actually we are trying that using that optical data itself.
Great, thank you, Raj. Arun has an excellent question about the storm surge forecast to the cities and this urban ocean notion. So, Nadia, I know you put a comment, but could you speak to that a bit? That's an area where CEOS Coast very much wants to and needs to work with Coast Predict, who's really going to lead those activities. So, Nadia, can you speak to that? Very important topic.
Well, we have the expert on urban development of coastal models. And so like Alan Bloomberg is leading a project that is inundation and there was a slide actually in my presentation where you saw all the taxis in New York inundated. And that was a very important test for the idea of having coastal models looking into the town, going into town with all the elevation. So you need very adequate elevation models going into the streets. And that example was amazing because actually the taxis were taken from one place to another without knowing that the sea would have arrived in the second place. So the inundation actually occurred, was predicted by the urban modeling that they do. So we consider the urban areas as part of the areas to be modeled. How much do we have information now from satellite? Don't know. But definitely there is a frontier there. And there is a book I recommend that is Urban Oceanography by Bloomberg, sorry, not Mellor, Bloomberg, that explains the kind of details that are needed, some new physics, drag coefficients and things like this. So very promising.
Great. Thank you, Nadia. So we're almost out of time. I want to follow up on the topic from Frank. Paul, how integral is social and economic information to COAST? I missed a presentation, but saw your code development. I would say that that question is essential for all of us in terms of linking data providers, for example, CEOS and COAST with the users. And again, really through that nexus of the forecast, the modeling and forecasting through COAST Predict. But I will just highlight an ongoing activity by the GeoBlue Planet Initiative that Frank's aware of this, but for the group to support UN Environment for information on SDG 14.1.1 on coastal eutrophication. And there's a difference between what data providers like CEOS and GOOS typically provide and what the information users like UN Environment want. And so I think that that's essential focus of our collective community, the observation side, the modeling, forecasting, and the end users over the next few years. I would guess ask if there's any last thoughts from the audience in terms of some other gaps that people haven't heard here or haven't heard enough, and given it's a short period of time. If you could just throw those into the chat, so because we could follow up offline about those. I would just ask for the panel if there's any last feedback or comments before we go into the wrap-up mode. So panel, either Raj, Doug, Nadia, or Rashmi.
Hi, Paul. This is Doug. I was just wondering, we've discussed some of the pilot projects, but for example, would there be interest in looking at this ocean climate nexus in terms of perhaps the influence of warming ocean currents or the shutdown of conveyor belts on fisheries? Would there be room to consider something along those lines?
Yes, Doug, and I would say that that's one where we're really looking over the next several years out, where CEOS Coast would really be, I see COAST Predict, Doug, as providing that nexus that you just mentioned, the connection between ocean and climate. There is for Ocean Predict, the broader basin scale ocean prediction activity that myself and Nadia and several others here involved in, is COAST Predict work with them for the boundary conditions, and then in turn transfer those down in terms of what information is needed from the CEOS Space Agency partners, from GOOS, et cetera. And so again, I really can't underscore how critical COAST Predict is to service in this nexus between the agencies upstream, providing the satellite observations, the field measurements, and the users. And so, Doug, I see a lot of that over the next year running through COAST Predict and really telling us from CEOS Coast, what their product and observation requirements are.
Great, thanks.
Maybe I would like to add, we might have in COAST Predict some dedicated action on mariculture and mariculture, coastal mariculture, and maybe local fisheries, not so much at the global level. Certainly, we have also local air system modeling that will be developed and for the coastal part. So.
Great, thanks, Nadia. And again, that's also where the integration with other UN decade programs and contributions like Marine Life 2030 that Frank was mentioning before, and likewise the 4C activity for the broader Ocean Predict. And so I think we have the right partners involved. I think we're looking at the right things, and now it's just to ensure that we really address, definitively what those user needs. So just in terms of wrap up, in terms of, we will be having some follow-up activities with CEOS Coast. If you're interested in learning more, email Mary Beth. You see her email there. Our CEOS Coast website, ceos.org/CEOS-Coast. We'll be having a CEOS Coast product showcase on October 5th, working with Geo, co-design and co-develop. And then in spring of next year, some regional co-design, co-develop workshops with specific geo users for those different regions that we mentioned. And again, we're interested in expanding to other areas for CEOS Coast. The Arctic and high latitude will most definitely be an emerging area. And yes, just to follow up on what Raj and Rashmi are saying, again, these questions and feedback are very important. We encourage everyone offline to weigh in. So I'll ask any last things, Mary Beth, or likewise our panel, any last comments before we wrap up?
No, just a big thank you to Geo for the opportunity to present at the virtual symposium. We also encourage you to use their coffee chat area, which they are enabling, I believe, after this session, and enjoy your virtual symposium for the next 3 days.
Great, and I want to thank Mary Beth for all of her hard work in organizing this session. I think we got a lot done in an hour. I want to thank our esteemed panel who are wonderful. And in particular, I want to thank Douglas Kripe in GEO. The GEO secretariat folks don't get enough credit, and just for all of you to be aware, Doug is amazing. And in terms of the time and attention he gives the coasts and the oceans in GEO. So Doug, thank you so much for your activities behind the scenes. And with that, I wish everyone enjoyed the rest of the GEO symposium. Please reach out to us for CEOS Coast and our partners here. And we're going to make great things happen this next decade. So thank you all. Take care. That concludes our meeting, our session. Thank you all.